The next step now is to apply the box morph. So I'm going to remap these armatures into the boxes themselves like you see here, and then figure out what I have to do to get it facing the right way. So I have my geometry right here. It's already mapped into this bounding box. And I can get rid of this stuff right now because I'm not going to troubleshoot it with point lists. I got rid of the point list stuff. I'm going to use the box morph function to actually map it in and then reorient it. So to do that, I really only need one more tool. That's it. It's just box morph, which is, I think it's under transform. Yeah. So under transform, under morph, you can grab this one right here. It's called box morph. And it's going to ask for the geometry that it's morphing. It's going to ask for the reference box, and then it's going to ask for the target box. So the geometry would be the armature that we modeled. The reference box would be the box that we mapped around it as its maximum extents. And then the target box is going to be the surface box, or boxes, or list of boxes, that we're going to map it into. So simply enough, the geometry gets plugged into morph. The reference box gets plugged in to morph. And the target box gets plugged into morph. So now if we go back to this, we see that we have our armature getting morphed in. So we must be aware, though, that the proportions might change. So notice how we've got this really, really wide disk, and then if you look at the side of it, this disk gets kind of ovular because it's kind of squished. So we need to change these proportions in order to fit something that is more appropriate. Okay, so we're going to make it look right after we get the right orientation. So I notice here that the thin part, well, it's kind of hard to tell because it's all morphed, but the thick part is on the right and the thin part is up front, which is good. The thick part being up front is what I want. So the cool thing is I can grab this geometry and just start rotating it, and it will rotate within the box morph. So for instance, if I just kind of drag this thing down and rotate it like that, you'll see that this thing gets all weird and funky and tries to stretch to the maximum value of the box morph. That's how it works. It just stretches that box reference to the entire extent of the new box. So if we want to do it by a particular orientation, then we have two options. We could rotate the reference geometry, or we can change the orientation of this box. I'm kind of more of a fan of just rotating the geometry till I get it right. But this should work too if you have a real strong command of the XY direction. But I know that we try to keep things very tactile and surface level, so I'm going to just rotate the geometry. So to do that, I'm going to focus in on which way does it have to rotate. So imagine that I'm taking the front face of this. I know that that's where I want it. So obviously, I want to rotate it around that face by a value of 180 degrees. Because I want this right here. I want this connection to actually be on that side. Which is easy enough to do. I know that the thickened part really, it's looking at it just like this, essentially. So I need to mirror this or rotate it right here 180 degrees. So now I'll go back here and you'll see that it's properly attached to the glazing, or to the glass fin. Making some sense? Yes?
Which way did you rotate it?
I know, it's hard to see. You basically could either reference this one or yeah, the original orientation was 180 degrees that way. So I just kind of, what I did was I moved my camera to look at it in the condition that it was in, and then I thought about the change that I wanted to make. And what I wanted to do was rotate it 180 degrees from what I see right here. So I clicked on that axis, typed in 180, and that's what did it. Okay, so now before I move into mapping all the rest of them, I want to get my proportions right. So I'll need to go back to my sliders. I can do a couple things. I can pull the depth of the sliders back to make them thicker, like that, and the proportion will get a little better. See, that's looking pretty good there. Let me select this so you can really see it. There you go. So that proportion looks a little better, but my fin is only a foot deep. In fact, I probably should maybe increase the thickness of my fin, but I'm going to try and keep it like this. So ultimately, I'm going to reduce many of the domains that I'm working with in order to just make it generally smaller. So I'm kind of okay right now with the vertical height. That probably will have to change as I reduce it, but let's select that so we can see it very well, and let's just start working on them. So you can kind of pull it like this to kind of see which direction it's going. So I know that 0.2 or 20% of the way out is kind of way too big. Additionally, 13 inches back is way too big as well. So if I want this to remain at 6 inches, then I probably, which is about half of that, then I probably want to reduce my Vmax by half as well. So that would be 10%. Yeah, 10%. Probably could go larger. I'm going to make this 0.15. Yeah, that's probably a little better. Now I noticed that it's kind of creating it to be a little bit too ovular here as well. So I'm going to reduce the, which ones are plugged in? So that would be these. So I'm going to reduce the height of this by a little bit too. So I'll change that to like 0.18 so that it's only 3% wide. That's a little better. Actually, I think 10% was the right move here. 0.1. There you go. So you kind of have to play with it until it just starts looking right. The downside of this is that it's not really accurate to like a hardware piece the way it would be engineered. So this is more of a representational exercise. Okay, be aware of that. That it's really only meant to give your larger, more complex models a little bit more believability, but not necessarily accuracy. Okay, I'm giving you guys a bit of a shortcut here. So anyway, I've sort of sized that one approximately to what I want. However, I changed the relationship of a few of them that I need to reflect in the others. So if I reduced my V minimum, V maximums to 10%, I need to change it to 10% the other way as well. So I'll make that 0.9. And then I want to reduce this value as well. So the maximum of U maximum of 20, I reduced to 17, so I subtracted 3 from it. So I'm going to do the same thing to the U minimum here. I'll subtract 3 from its distance from the edge, which would be a value of 1. So it's actually going to add 3. I know, it's super confusing, guys. So 0.83. And so they're going to be identical on either side. Okay, so guys, I just want to quickly close the thought here, and then we can work on the proportions and getting it all kind of thought up, or filled out rather. The only thing you're going to have to change is the connection and potentially the the geometry down here. So I made two. Those two geometries are going to be in different orientations, like this. I had them facing each other like that. So basically, if I copy this morph up and I apply it to a one of these that's in the same orientation. So I made the top left in that orientation. So the bottom left is going to be in the same orientation. So I'll select the bottom left and plug it into the target box input of that box. And now that gets populated down here. Okay. And then the other thing we have to do now is, if you wanted to change using your planes, you could do it with a separate bounding box down here, or you can basically just select this whole configuration and move it up, and then plug in your other boxes and see what it looks like, see if it's the proper orientation. So that one's not. So now I know I need to have it rotated to the other side. So I'll select that other geometry that I created that's facing the other way. That one. See, now they're both referenced. And if I go back to my model, this one's facing now the right way. It's a proper spider clip. Clear as mud. So then the last thing I just need to do is copy that up and get my other complementary one and plug that in. And so now all of my hardware is properly applied. Pretty fascinating, right? I know. So I do want to just quickly introduce to you guys one more final thought, and that's this down here. If you look at it from the top, it looks like it's kind of right on the edge. Be aware that that might not necessarily be exactly where it needs to be. And what I mean by that is, if you turn on your ruled surfaces, you'll notice that the glass is kind of behind. So in order to adjust this to look a little more convincing, keep in mind that it's not going to be perfectly physically accurate if you're going to use this method. You can basically just increase the thickness of this pad, and it should be able to accommodate some of that. Or you can reorient the box to be clipped by this to run against this panel instead, basically, rather than the curved surface. So that would basically mean replacing this subdivided panel with your individual faces instead. I know it's a little confusing, but and it's going to tilt it too. So I mean, there are any number of things that you can do with this. The reason I gave you this simplified version is because it's a super duper quick way of getting something that looks reasonably intriguing. Do I still have my other model open with the full thing? Yeah. So my hardware is a little bit bigger, and in fact, you know, the warped glazing and stuff isn't necessarily correct, and that can be corrected by reconfiguring it in some way. But essentially, if I have a series of these, let me just go through and kind of copy this whole thing up. Let me copy a few of these real fast so you can just go one there, and I'll rotate it. So now the cool thing about this really is, and I've got this one set up already, I'm just going to be remapping a few things. There we go. you essentially can just take this list of curves and start applying new lists of curves as well. So I can copy paste, and I can say set multiple curves, and I'll select this curve and that curve. And I wonder if it'll let me pass them both through. Whew, no, that won't do it. That's funny. Hang on. Sometimes you will. There's probably going to be a way you can reduce the redundancy. I'm trying to figure out where. It'd probably be here. It'll probably be there. But anyway, you can copy it 3 times too. Copy that. That. And it's really just going to be as simple as swapping this out. Oops. Curve. Go to the next one. You can do this one too. Okay, so I know I'm running long, but I just wanted to show you how easy it is to basically take this as a completed thought, bring it into a new model, and apply it to something else, and it'll repopulate. And you can change, now that I've got all 3 of those set up, if I wanted to change the subdivisions, I can go up to 5 or 6 or 7 or 8 subdivisions there. I can do horizontal subdivisions as well. Of course, the only thing you're going to have to do then is modify your hardware to make it a little more convincing too. Okay, so with that, what other questions do you have? I'll go back to the other one so you can, there you go. All right, so I'm going to stop this video. It went way too long, I'm sure. I'll let you guys get caught up on this, and then that'll be it for tonight.